Hello there, welcome to our third lesson on integration. In the previous lesson, we learned on how to determine the arbitrary constant c, which we noted is only possible if you're provided with some additional information. In this lesson, we will learn about definite integrals, what they are, and how to evaluate them. In addition, we will learn how to find the exact area under a given curve. Now, suppose we wish to find the exact area shaded beneath the curve as shown in the diagram below. Now, there are several methods which we can use to be able to determine the area shaded as indicated in this particular diagram. We can use the counting technique, we can use the trapezoidal rule, we can use the mid-ordinate rule. Now, when we wish to find the exact area under the curve, any of those particular methods cannot be able to give us the exact area, and hence the need to find a method that gives you an exact area bounded by the curve and between the provided limits. And that particular method, as we shall be able to discuss, is only possible by using the definite integrals. Now, the area in question can be subdivided into rectangular strips in two different ways. The first one is by dividing the provided area into 4 strips, ensuring that all these strips are below the provided curve. The second one will be subdividing the area under the curve into 4 strips, and each of these particular strips goes beyond the curve. Notice that the area in A will be an underestimated area, and that in B will be an overestimated area. Notice that the actual area lies between the underestimated and the overestimated area. In each case, the accuracy can be improved by increasing the number of rectangular strips between x is equals to A and x is equals to B. The figure below shows a typical strip extracted from figure A. Further, notice that we can choose delta x small enough to reduce the length of a rectangular strip to y. The area of this strip is y delta x. The area beneath the curve is the sum of all the areas of such strips that can be fitted into the region. Thus, the area beneath the curve between the limits x is equals to A and x is equals to B will be given by area being equal to summation from the limits x is equals to A to x is equals to B, y delta x. The exact area is found by limiting the value of the sum as delta x tends to 0 and will be written as the integral from A to B y delta x. The symbol, this symbol over here, is an instruction to integrate, and it is referred to as the integral symbol or the integral sign. Thus, when you have that integral sign y dx, it basically means integrate the expression for y with respect to x. And when you have the integral sign with A and B being placed in such a manner, y delta x, it basically means you integrate y with respect to x and evaluate the resulting integral for the limits A to B, and such an integral is referred to as a definite integral. And the A and the B are referred to as the limits, with A being called the lower limit and B being called the upper limit. Now, in the case where we do not have the lower and the upper limits, like in this particular case over here, that basically we call it an indefinite integral. Let's take an illustration. Consider the definite integral, the integral from 2 to 6 2x squared plus 3 integrated with respect to x. The steps for evaluating this particular integral will be as follows. Step number 1, integrate 2x squared plus 3 with respect to x, which will give us 2 over 3x cubed plus 3x plus the arbitrary constant c. Step number 2, place the integral in the square bracket and insert the limits as indicated over here. Step number 3 is to evaluate the resulting integral for the provided limits. For x equals to 6, which was our upper limit, the integral will be evaluated, and that gives us 162 plus the arbitrary constant c. And then for the lower limit, when we evaluate our integral, we are going to get 34/3 plus our arbitrary constant c. Step number 4 is to subtract the result of the lower limit from that of the upper limit, and that will give us 162 plus the arbitrary constant c subtract 34/3 plus the arbitrary constant c, and that gives us 150 and 2/3. Now you'll notice that the constant c cancels in the process of subtraction, and basically if you were to open the brackets over here, and then this will be able to give us 162 plus the arbitrary constant c minus 34/3 minus the arbitrary constant c. So this constant that is added in the first expression cancels with this other one over here, so that we are ending up with 162 minus 34/3, which gives us 150 and 2/3. So basically, to evaluate a definite integrals, these are the 4 steps that you're going to take for you to be able to determine what the value of that particular integral is going to be. These 4 steps can be summarized as, remember, we are integrating from x equals to 2 to x equals to 6 to x squared plus 3 with respect to x. And once we integrate what we have in brackets, we're going to have 2/3 x cubed plus 3x plus the arbitrary constant c. And then we place our limits as indicated over here. This is the lower limit, and then this is the upper limit. So we place them in such a manner, and then once we've done that, we evaluate our integral for the upper limit, beginning with the upper limit, and that is going to give us what we have over here. So 2/3 into 6 cubed plus 3 into 6 plus the arbitrary constant c. And then we always subtract the evaluation of our integral at the lower limit. So minus, we have our square brackets, 2/3 into 2 cubed plus 3 into 2 plus the arbitrary constant c. And once we do that particular subtraction, you're going to have 150 and 2/3. So you don't really have to follow all the 4 steps. As long as you know how to do the integration and you know how to evaluate your integral for the provided limits, you integrate, evaluate the resulting integral for the provided limits, and provide your answer. Let's look at an example. Evaluate the integral from 0 to 1 x to power 4 minus 5 dx. And then for the second one, we have evaluate the integral from -1 to 2. And then in brackets, we have minus x cubed plus 5x minus 2 dx. And then the last one is the integral from 2 to 3, 3x cubed minus 4x plus 5 in brackets dx. So you want to see how do we evaluate these 3 integrals for the provided limits, and we are going to find that for each of these, then the solution is found as indicated over here. So for the first one, you're going to have the integral from 0 to 1 x to power 4 minus 5 dx. So integrating what you have in brackets, you're going to have x to power 5 over 5 minus 5x plus the arbitrary constant c. And then we place the limits also as indicated over here. So we have the lower limit as 0, and then we have the upper limit as 1. So remember, this is the upper limit. So let me just indicate that, upper limit. And then this is the lower limit. Now, once you've done that, the next step will be evaluating our integral for the upper limit and then subtracting the lower limit from that of the upper limit. Then you're going to have 1 raised to power 5 over 5 minus 5 multiplied by 1 plus the arbitrary constant c. And then evaluating our integral at the lower limit is going to give us 0 over 5 minus 5 multiplied by 0 plus the arbitrary constant c. And this will result to having minus 4 and 4 over 5 as the result from evaluating this particular integral over here. Similarly, the second one will be evaluated by first integrating what we have in brackets and then evaluating the integral for the provided limits, and that will give us minus x to power 4 divided by 4 plus 5x squared over 2 minus 2x plus the arbitrarily constant c. And then so that's what we have over here. And then we have our limits. Again, remember, minus 1 is the lower limit and 2 is the upper limit. We therefore proceed to evaluating our integral for the upper limit, and that will give us minus 4 plus 10 minus 4. And then we evaluate our integral for the lower limit, and that is going to give us minus a quarter plus 5 over 2 plus 2. And then we finally subtract the results of the lower limit from that of the upper limit, and that will give us 2 minus 4 and a quarter as indicated over here. And the final result becomes minus 2 and a quarter. The third one will also be evaluated by first integrating what we have in brackets, and that will result to having 3/4 x to the power 4 minus 4 over 2 x squared plus 5x plus the arbitrarily constant c. And then we indicate our limits as indicated over here. Remember, 2 is the lower limit and 3 is the upper limits. We then evaluate our integral, which is 3/4 x to the power 4 minus 4 over 2 x squared plus 5x plus the arbitrarily constant c for the upper limits, which will give us 27 minus 18 plus 15 plus the arbitrarily constant c. And then we shall also evaluate our integral for the limit of x equals to 2, giving us 8 minus 8 plus 10 plus the arbitrarily constant c. And therefore, the working from that gives us the results as being equal to 20. So therefore, our integral of 3x cubed minus 4x plus 5 for the limits of x equals to 2 and x equals to 3 will be equal to 20. Practice what you've learned in this lesson by pausing the video and trying working out these questions. In summary, in this lesson, we've learned that this simple is called the integral sign or simple, and is an instruction to integrate. And therefore, every time you are seeing that particular simple, it basically means integrate. We've also learned that if you have that particular simple with the limits being indicated, maybe a b and then y dx, we say that this is called a definite integral, and it will involve you integrating y with respect to x and then evaluating the resulting integral for the limit x is equals to a and x is equals to b. That's all for now. See you in our next lesson.